Hello and welcome to this PV Tech Talk webinar in conjunction with Yingli Solar. The title of this webinar is Understanding the Evolving Customer Demand of Residential Solar PV. My name is Sean Roach and I'll be your host for today's webinar. Joining me today is Ron Williams, National Account Manager at Yingli Solar, and George Farney, Business Development Manager at Yingli Solar. Ron will explore Yingli's current suite of offerings and the evolving customer demands of residential solar in the first part of this presentation. And then George will take over to examine the evolution of PV cell technology and what it means for deployment in different contexts. But before we start, a bit of housekeeping from me. Today's webinar is going to last around 1 hour and will include opportunities for audience questions. You can use the dialog box on your screen to submit those questions. The webinar is also being recorded and will be available on demand via PV Tech later today. But without any further ado, I'll pass over to our first speaker, which is Ron.
Thank you, Sean, and thanks also to the PV Tech team for hosting this webinar. George and I appreciate the opportunity to discuss the evolving customer demands of residential solar and share with you all some simple solutions. Good morning, afternoon, or evening, everyone. I'm very pleased you could join us. As we are based here in the Sydney, New South Wales region, in the spirit of reconciliation, Yingli Solar acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Just to clarify, even though our team are located here in Australia, this information will be relevant worldwide. However, there may be a few points more pertinent to our Australian-based viewers, simply due to our local incentive structure driven by renewable energy certificates, but I'll explain more in due course. Firstly, I'm sure most of you will already be familiar with Yingli, as we have a very long and proud history in the renewable energy industry. However, for those of you who are unaware of our story, I'll attempt to condense our 24 years of innovation into just a brief overview. Yingli have been manufacturing since 1998 with over 35 gigawatts of solar panels installed globally. Due to our substantial research and development investments, we are an industry leader in PV patents. This has put us in good stead as it has proven over the decades to be a contributing factor to our product reliability in the field. Our team have been based here in Sydney for over 10 years now, and we currently service Australia, New Zealand, and the Pacific Islands from this location. We are a Bloomberg NEF Tier 1 company with independent product quality testing performed by both PVEL and RETC. Yingli was a very early participant in the Australian Solar Panel Validation Initiative, which aims to ensure that the end user receives the genuine, fully warranted, and CEC approved product they are expecting. As Yingli is a true pioneer of our industry, there have been many firsts for us, such as the first 3 megawatt solar production facility way back in 1999. In October 2003, Yingli produced the first polysilicon ingot in China and quickly began commercial production and worldwide distribution. Our module production capacity also continued to grow exponentially from 3 megawatts to 600 megawatts in just 10 years, then quickly escalating to 2.3 gigawatts in 2012. This achievement resulted in Yingli being the largest PV manufacturer in the world by shipment volumes, and we managed to maintain our position as leader in 2013 by increasing our volume to 3.2 gigawatts. In 2016, we led the development of the first clean production evaluation system for China's PV industry. Today, our capacity continues to grow, as does our product development. It may be a little bit difficult to read the smaller print on this slide. However, you will be able to access this presentation afterwards to view all of the bullet points individually. Yingli was the first renewable energy company to bring solar to the world stage by being a major sponsor of the FIFA World Cup with billions of viewers. If you look at the signage around the field, you'll see our name proudly displayed, as is a fast food company who also seem to be doing okay. Yingli have always been a strong participant of environmental, social and governance, with particular emphasis placed on our people, processes and product. We were a very early adopter of the WWF Climate Savers Program, the SPV initiative, and a long-standing partner of Reclaim PV Recycling, just to name a few. So that's a quick rundown for our journey so far. Let's look at today. It seems that the evolving customer demands we all face right now are centred mainly around the need to fit larger systems onto homes and/or businesses. This is being driven by many factors such as battery energy storage systems, EVs, increased energy use while working from home, or of course the continuing increases in energy costs. Yingli have developed a range of high energy density modules to maximise the potential of each individual installation. The main product we will be focusing on today is our 415 watt by 108 cell PERC mono module, as we believe it offers the installer the greatest flexibility in design and is also considerably easier to handle than the larger commercial or utility scale modules. If you are blessed enough to have wide open spaces of rooftop accessible to you, then we do have the other options available as well. We generally keep both monofacial and bifacial versions of our 550 watt by 144 cell PERC mono modules right here in Australia, and even have some of the mighty utility scale bifacials if required. Another customer concern can be trying to decide on the best system to buy, given the vast array of brands and configurations available. Being able to provide your client with peace of mind is a very important factor in this decision. Fortunately, Yingli have always had a great reputation for the reliability and performance of our products. We are one of the few manufacturers who have been producing modules for almost the 25-year warranty period, and I believe we are well positioned to provide your clients with confidence in both our product and our brand. Our current RETC High Achiever Awards for product manufacturing, quality, reliability, and performance should only enhance that. However, if further documented third-party testing is required to support your offer, we also have a current PVEL report available. This slide provides you with a snapshot of our local Australian solar uptake, combining residential, commercial, industrial, and utility scale. I believe we are doing pretty well for a small country, with over 3.19 million installations and 27.2 gigawatts installed as at the 30th of June 2022. This can also see that the residential sector is very strong, making up around 1/3 of the total capacity installed. With our current population being just over 26 million, this equates to just over 1 gigawatt per every million inhabitants, or more simply, just over 1 kilowatt per person. But the real message here is solar installations are expected to grow very quickly from this point onward. The target is for 82% of electricity to come from renewables by 2030, which is not very far away. There is new legislation here, which will only enhance the continued increase of solar uptake. So hold on to your hats, everyone. It's about to get even more interesting. A major contributor to the pending growth is still expected to be the residential and small commercial sectors. Distributed energy, when combined with battery energy storage systems, makes a lot of sense in regard to energy security and hedging against continually inflating energy costs. That's why we believe our 415 watt by 108 cell module can help you to maximise the energy density installed per roof due to its compact size and the ease of handling. It ticks all the boxes, such as a 25-year product and 25-year performance warranty for both residential and commercial installations here in Australia and New Zealand. It's backed by a strong Tier 1 manufacturer, Yingli, and has successfully passed third-party independent testing for quality, reliability, and performance. It also fits nicely into the very common system size here in Australia of 6.66 kilowatts. For our global viewers, the reason for this popularity is that it maximises the renewable energy certificates, known as STCs, where for a 5 kilowatt inverter, you can use a multiplier of 1.333 to establish the amount of panels that you can claim. This panel is constructed of all the right components using multi-bus bars, gallium doping, and other durable state-of-the-art materials. However, one of its main advantages is a combination of module efficiency and its compact size and weight. 1722 millimeters by 1134 millimeters by 30 millimeter frame provides excellent rooftop packing density, reduced logistics and warehousing costs. It can also save you time on the roof and balance of system costs. This product comes with a black frame, 1200 millimeter leads, and Evo 2 connectors to make it very simple to use with optimizers or microinverters. It has the sleek, aesthetically pleasing appearance and gives you greater design flexibility, especially on busy roofs. You can see that this 5 kilowatt array leaves plenty of room on this particular roof to work around safely. In fact, these higher energy dense modules can save you time on a roof, which is not only cost saving, but also a safety advantage. The less time you're on a roof, the less exposure you have to safety issues and or even weather events disrupting your installation. There are also cost savings for the balance of system, and if you can avoid using another roof orientation, thanks to higher density modules, you could possibly avoid the time and expense of extra edge protection. Our industry, and indeed others, have all experienced massive increases in shipping costs. Transport has also become more expensive and can take longer due to staff shortages at the moment. By increasing the total kilowatts in each pallet, and hence each container, we can minimise the impact of this to yourselves and the end user. There have been significant improvements made in this area, as shown in this table. Even just comparing the 370 watt module to our 415 watt, we can ship over 34% more power per container, which makes a big difference. This then filters all the way down the line. It reduces the amount of space you need in your warehouses. It can reduce the amount of time required to prepare an order. It can reduce the amount of space you need on your trucks or the transport costs to deliver them. It can also reduce the amount of crane lifts for a commercial job or the amount of times you or the apprentice has to climb a ladder, which are also minimising safety risks. All of these considerable benefits just from fitting more power in a pallet. Yingli have and will continue to invest heavily in research and development. The key goal of this investment is to be able to provide the most reliable and efficient module available with the most competitive levelised cost of energy. The gains that we have made over the years is coincidentally evident in this power packing density graph. It realistically wasn't that long ago that we were shipping off containers of 270 watt modules holding 227 kilowatts in total. Today, our 415 watt containers deliver 388 kilowatts at a time. That's quite a considerable difference in quantity, and yet the total cost of each container was very similar. Put simply, just 5 short years ago, if you ordered a container of residential modules, we would have shipped you 227 kilowatts of 270 watt panels. Today, we would ship you 388 kilowatts of 415 watt panels, and the total cost for each container would have been very similar. Looks like all that R&D investment is working. So in conclusion of my part of this presentation, let's recap and summarise. You can see some of the evolving customer demands listed down the left-hand side of the page, which we've touched on earlier, such as the onset of EVs, working from home increasing the demand for domestic energy, and high electricity costs and how low feed-in tariffs are encouraging the uptake of battery energy storage systems. Then on the right, you can see how our 415 watt by 108 cell product can help to provide solutions for some of these evolving customer demands, such as the ability to fit more power on a roof, fewer modules save on balance of system costs, and can reduce installation time. Being able to overdrive your inverter can provide more kilowatt hours of energy during mornings, afternoons, or cloudy conditions. The compact size, which by the way, quite often works better for metal roof batten spacings, can allow you to gain more yield from the available roof space, which I believe is the crux of the issue, and with added benefits of saving time, costs and minimizing possible safety issues, it could well be worth your while to consider this module as your possible solution. Our email addresses will be on the final slide, so please feel free to touch base if I can help you with anything. Thanks again, and I'll hand you over to George to continue our presentation.
Thanks very much, Ron. Welcome, everyone. Firstly, let's review the cell technology evolution and discuss how cell efficiency and power per square metre of the residential solar panel has advanced and how this benefits product distributors, installers, and homeowners alike. As established solar panel manufacturers, Yingli aims to, 1, produce highly efficient and stable solar products that will last for decades in the field. Number 2, manufacture products ethically and sustainably. And number 3, we also need to manufacture products economically to meet growing demand and to attract a wider market. The more efficient the solar panel is, the more solar electricity we're able to generate per square metre, and this translates to using less resources and energy to produce these solar panels. We also need to keep in mind that the average home has a limited amount of roof space, and demand for renewable power is increasing, especially with the emerging electric vehicle market and the rise in the digital economy. Over the last 3 decades or so, poly and monocrystalline modules produced using traditional back surface field technology have dominated the market. However, panel efficiency was limited, peaking in the range of 15 to 18%. In the last few years, PERC mono, or passive emitter and rear contact cell, have taken the lead, with virtually all products and demand shifting to these higher efficient and mass-produced cells. Levelized cost of energy using PERC mono modules has vastly improved to the point where traditional poly and monocrystalline modules are no longer in demand or in development. Some of the early challenges, including light and elevated temperature-induced degradation, have been suppressed by substituting boron-doped silicon with alternatives such as gallium. Today, our 3.0 PERC mono cell used in the Yingli 415-watt panel is not only more efficient, delivers panel efficiency well over 21%, they also operate more efficiently at higher temperatures, they capture a broader spectrum of sunlight, and are more stable over time, making them ideal for the residential market. The PERC mono is currently the most cost-effective technology on the market, and this means that this type of semiconductor will continue to be supported well into 2023. We know that solar panels output, particularly current flow, is proportional to the amount of sunlight, and therefore any form of partial shade will result in less energy production. There's also other technical challenges, such as heat buildup within the cell, which may accelerate material degradation. A good solar designer and installer will therefore try and avoid positioning any solar panel in a shaded location, because even with the addition of external optimization equipment, you can't get around the fact that less sunlight means less solar power. Power loss due to shading may occur for other reasons, such as, for example, a low sun angle in winter, or during morning and afternoons on a tilted solar system, or when dirt build up along the lower sections of a pitched solar array that hasn't been cleaned for a while. Yingli designs these panels with an electrical string layout that connects all 108 cells together, yet separates the 2 equal halves of the module with blocking diodes in 3 junction boxes to improve performance. In this solar system example, you can see a tilted solar array installed on a roof. Each solar array is installed in rows running parallel to each other. Now at noon in summer, the system will operate at full power with no issues. However, at low sun angles, a shadow may cast onto the lower half of the adjacent array. Traditional solar panels in this scenario would produce close to, if not zero output. Using the latest optimized cell layout and bypass diode design, Yingli solar panels will continue to operate and generate 50%, meaning there's more power available to meet the homeowner's electricity demand, or the extra energy can be directed and stored into a home battery or EV for use at a later time. In addition, our solar design is optimized to operate cooler at higher irradiance levels because resistant levels are reduced, and the system voltage drop is minimized at higher temperatures, resulting in improved system longevity. That's important because in the world of material science, there's a rule of thumb that states that for every 10-degree rise in temperature, materials would generally degrade at double the normal rate. Here we'll discuss the dimensions and weight of the 108 cell panel. It's compact, under 2 square meters, and weighs in at just 21.5 kilos. It's small and light enough for one person lift. This makes it ideal for the home solar systems. The module electrical characteristics are also noted here, and most of the top brand inverter manufacturers are generally a good fit. Ron has detailed Yingli's manufacturing history, demonstrating a lengthy manufacturing learning curve, whereas some other manufacturers may offer a limited warranty period of 10 or so years. Yingli can justify its 25-year product warranty and 25-year performance warranty, having mass-produced solar panels since 1998. There's a fine balance between aesthetics and performance when it comes to choosing a solar panel for your home. Our premium all-black module incorporates black cells, backsheet, black anodized aluminium frame, and main bus bars. At the moment, the standard 415-watt 108 cell white backsheet module outperforms our all-black module, coming in at slightly higher power class relative to the black module. This is because the white backsheet material can reflect light back into the silicon structure, thereby boosting power output, whereas the black backsheet itself absorbs light, so its output is slightly less. For some homeowners, the interest in a sleeker looking all-black module may outweigh any small reduction in power class. It's another way of adding value to the look of your home and its potential future selling price. So on one hand, we have a home solar plant that not only saves money and the environment, but for some homeowners, it just looks nice. Okay, let's take a review of the multi-bus bar technology that's used in the Yingli 108 cell module. Bus bars are electrical conductors that typically run along the cell surface, and the purpose is to efficiently transfer electrons across the cell and out through the external circuit. Without these bus bars, the cells will be highly resistive, particularly at high irradiance, and overall power will be a fraction of the cell's peak potential output. Too many bus bars, and you start to cast a shadow on the cell surface that blocks the sunlight and reduces the active or functioning area of the cell. Multi-bus bars offer another advantage. They physically and electrically hold the cell together, so in the event of a cell cracking due to poor handling and installation work, for example, electrons will continue to flow. You may come across some photos on social media showing people standing on solar panels. We don't recommend that you stand or walk on solar panels because that would void the warranty, and manufacturers do have a way of identifying the shoe that caused the damage. As you can see from the image here on the left, the earlier cell designs use a minimum number of bus bars, 2, or in this example, or possibly up to around 5. Should a large enough crack form within these cells, electrons cannot flow easily or may be blocked, therefore overall power reduces. Electroluminescent testing is one way of identifying any fractures within these cells. The darker section of the cell shown here makes up about a quarter of the cell's area, which means that a quarter of the cell's power is basically rendered inactive. By implementing thinner and multiple bus bars, at least 10 or more in our 108 cell module, there's a higher probability that the cell will continue to perform even in the event of a crack forming. Quality manufacturers will use electroluminescent testing to identify any bad cells in the manufacturing and assembly process. By running current through the modules, the semiconductor cells emit light, and the dark areas can be examined for any possible defects. It's like taking an X-ray image and looking for microcracks within the cell structure, though without the X-rays. There's at least 4 EL tests conducted during the manufacturing process, including during the cell stringing process, pre-lamination, post-lamination, and final pre-packaging stage. This high level of quality assurance ensures no crack or defective module leaves the factory. Another feature of the Yingli 108 cell module is the wider, more flexible clamping zones. In this example, the installer is mounting the 108 cell module on a pitched tiled roof. In this case, the racking system is fixed to battens that run beneath the tiles. The batten spacing in some cases might dictate where along the frame you can clamp. So there's a need to accommodate some flexibility here, providing you're operating within allowable clamping zones so you can still maintain peak structural integrity and strength. The 108 cell instruction manual will provide guidance here. Yingli does have the capability to also test some alternative clamping zones for specific projects, although the mechanical load limits may vary and is largely case by case. In this example, you can practically see how far we'd advanced in the less than a decade of improvements in both the cell and the module technology. What we see here is a rooftop aerial view comparison of the same house, each mounted with 10 kilowatts of solar panels. If we use modules manufactured back in the year 2014, you'd require at least 40 panels to produce 10 kilowatts of peak power. And we'd need to cover almost the entire north-facing roof, north being the optimal side here in Australia. Today, we only need 24 108 415 watt modules to reach the same 10 kilowatt peak rating. Installing higher efficient panels such as the 108 cell 415 watt Yingli module also reduces the amount of balance of system components. For example, reduced aluminium and stainless steel mounting equipment, reduced wiring and cable protection. With less connection points, we have lower resistance, and this reduces the potential points of failure. Using higher efficient 415 watt modules will improve the system energy yield. In other words, more kilowatt hours can be generated throughout the day, not only due to the better cell performance, but this improves system design. Say you want to install an extra 1 kilowatt or more using the lower efficiency modules, you now need to utilize a less optimal roof side, and that side will generate less energy and increase system balances, system costs, because you'll need extra power conversion equipment in the form of optimizers or microinverters to better manage the now unbalanced electrical arrangement. Aesthetics we touched on earlier, noting panels are now better looking, more densely packed within the black anodized aluminium frame. Also, the cells are darker in appearance, which essentially means the cells absorbing more light and reflecting less, which again improves aesthetics and efficiency. Less modules on the roof for the same amount of power means you install the solar system quicker with less handling costs and therefore reduced labor costs. Less time spent on the roof means a more economical system to the end user and a safer installation for the installer. On the flip side, it also means that you can add more watts for the available roof space should you require more power in later years. More available roof workspace around the perimeter of the rooftop solar system supports a cleaner and safer working environment for the installer. Also, having less panels on the roof reduces the overall weight of the solar system, meaning less stress on the roof structure itself. The amount of roof penetrations required to physically attach panels to the roofing structure is also reduced, which means there's less use of power tools and installation related work, which again provides a safer working schedule for the installer. As Ron referenced earlier, fitting more panels or watts on a pallet effectively reduces logistics costs. We save on fuel in transportation goods, we save on warehousing costs, we save on packaging material, and we reduce resources, and we reduce the overall cost of the system.
Hey, George, I'm sorry to interrupt you. I just found that really interesting. I'm wondering if you could explain a little bit more about the packaging and the reduced paneling and how they relate to that safety element, please.
Sure, Sean. With more efficient and economic solar panels, we save packaging for the entire supply chain, from the factory floor materials right through to the global logistics and local installation packaging handling. We're effectively reducing the amount of touch points and resources, and we get a safer and cleaner outcome for the environment. Even smaller systems, such as the popular 6.6 kilowatt home systems being installed here in Australia, can benefit by using the 415 watt 108 cell module. The competitor offering of 370 watt or 390 watt modules are still distributed throughout the market. Use these and you'll require up to 2 more panels to deliver the targeted system size of 6.6 kilowatts. Same thing applies here: more racking, more work for the entire supply chain, and ultimately a lower grade outcome for the end customer. In this example, we'll look at how we can better manage exclusion zones and improve the packing density of the solar system on the roof. The example on the far right is a competitor's 390 watt panel, which has a lower wattage and a longer frame length than the 108 415 watt module. Although you can safely pack in one row and maintain a safe and compliant work zone and support a structurally sound installation, you're only fitting 4.3 kilowatts of solar. In the next example, using the same 390 watt panel, you can barely squeeze 2 rows to get 7.8 kilowatts. However, in this case, you'll run the risk of an inspector defecting your system for compromising edge exclusion zones, and there's a risk to the system performance, warranty, safety, since the system installation is non-compliant. In the third example, using the latest Yingli 415 watt modules, 2 rows can safely fit within the available roof space. The safety standards are met, and you can deliver a larger 8.3 kilowatt system for the homeowner. We'll now take a look at some case studies of Yingli solar panels installed around the world over the last few years. Here's a good example of a recently installed residential solar system in Queensland featuring the 108 cell. This one uses a black frame with a white backsheet. The uniform lines add value to the overall aesthetics. Here we can see good examples of big brand names like IKEA choosing to use Yingli modules for their facilities in Sydney. It's a 1 megawatt rooftop system installed back in 2014. Another system, a 592 kilowatt system installed on the Harvard University facility in the US way back in 2012. And another smaller utility system at 5.8 megawatts in South Australia, which was installed in 2019. In New Zealand, we supplied our N-type TopCon module to this ground mount system. The cells here are active on the front and back, which boosts the output, particularly on a cloudy day where light is scattered. An interesting fact about this system, the modules were partially purchased using Bitcoin. I'm pretty sure we made more profit selling Bitcoin than we did selling the modules on this project. Other examples shown here include the first large-scale combined wind and solar site in Australia. Another example, the 5B portable ground mount system, is a good example where we were required to test an alternative clamping zone. In the UK, we have supplied large rooftop commercial solar systems back in 2014 at the Jaguar Motor Manufacturing Centre. In the outback of Australia, we supplied 9 megawatts to a series of remote Aboriginal community sites, partially funded by local government back in 2016. Thanks for tuning in. As you can see, there's our emails here for Ron and myself. So if you have any questions, please feel free to shoot through and we can answer them after the session. And I'll pass you now through to Sean, and perhaps we can take some more questions today from the audience.
Absolutely. Thank you very much to both of you. That was really insightful. So we've reached a section now where we can take audience questions. So this is a quick reminder to everyone watching that you can submit those questions using the questions tab on your screen. But quickly, I just have a few questions I'd like to follow up with you both. So George, I was wondering what connectors are attached to the panel and are they compatible with micros and optimizers?
Yeah, Sean. So the connectors that come on the 415 watt panels are typically the Stobley Evo 2 connectors. So those are compatible with the microinverter and optimizer technologies. Obviously, part of the standards around, particularly Australia and around the world, I imagine, you have to make the same connectors with the same brands. So you can actually, if you need, you can actually cut the connectors and use your own connectors, provided that you're obviously following the instruction manuals for the connector suppliers.
Okay, thank you for that, George. And then also, I suppose, how does the all-black panel perform relative to the white backsheet panel?
Yeah, so the all-black model obviously has using the black backsheet relative to the white backsheet. So if you're looking at power ratings, effectively the all-black module will give you around about 10 watts lower in power class to the white backsheet. As I mentioned earlier, that's because the black backsheet absorbs light. It doesn't reflect it, obviously, as well as the white backsheet, whereas the white backsheet does tend to allow light to reflect back off and back into the semiconductor to actually boost your performance.
Okay, thank you, George, for that. Ron, I was just wondering if you could explain maybe a little bit about how often you need to clean the panels and some maintenance stuff.
Yeah, sure. Thank you, Sean. This can vary significantly as it depends on a number of factors: roof pitch, location, how often it rains, if the local environment is dusty or near busy roads, or even if you live close to an industrial area. In an ideal scenario where the roof is on a normal angle and it rains frequently, then the panels tend to stay pretty clean. However, if it's not the case, then a regular wipe over will definitely make a difference. Fortunately, you can generally get a good idea on how your system's performing from the inverter or micro information app that most systems have these days. Or if the system's easily visible to you, just check it out occasionally to see if it's dirty. I usually clean mine once a year, but they're still pretty good at the moment due to all the rain we've had. Having said that, though, it's always a good idea for the end user to organise a regular inspection with their installer, just to keep an eye on the entire system.
Okay, thanks for that, Ron, as well. I'm just also wondering, for our viewers, where can our viewers find Yingli panels in Australia at the moment?
Yeah, that is a good question. Thank you. Probably should have mentioned that bit. Fortunately, we have a group of trusted distributors who have a wide coverage across Australia and New Zealand. It'd probably be best just to drop either George or myself a line, let us know where you are, and then we can direct you to your nearest outlet.
Okay, that's great. Thank you very much, guys. Unfortunately, everyone, that's all we have time for today. This is just a little reminder that today's webinar will be available on demand shortly, so you can go back and view it. Thank you once again to Ron and George for their time, and indeed for our audience for your attention today. Hope to see you again next time.